The ever-changing brain, an introduction to neuroplasticity. For centuries, the human brain was considered a fixed and unchangeable entity after a certain age. This static view has undergone a radical transformation in recent decades. We now understand the brain possesses a remarkable ability called neuroplasticity. Neuroplasticity refers to the brain's capacity to reorganize itself throughout life. This reorganization occurs in response to experiences, learning, and even injury. Our understanding of this dynamic organ has opened up new avenues for treating neurological and psychiatric conditions. Conditions once thought to be permanent can now be addressed with innovative approaches that harness the power of neuroplasticity. Among these are transcranial magnetic stimulation, electric stimulation, and deep brain stimulation. These techniques offer hope by directly modulating brain activity and promoting positive changes in neural circuits. In this exploration of neuroplasticity, we will delve into the mechanisms and applications of these cutting-edge treatments. We will uncover how they are being used to treat a range of conditions, including depression, anxiety, Parkinson's disease, and chronic pain. Join us as we unlock the secrets of neuroplasticity and its profound implications for healing and recovery. Unmasking neuroplasticity, its power and potential. Neuroplasticity is the brain's inherent ability to change and adapt throughout life. It is the very essence of learning, memory, and recovery from injury. Imagine a bustling city with streets constantly being rerouted, buildings remodeled, and new connections established. This is a glimpse into the dynamic world of our brains. At the heart of neuroplasticity lies the synapse, the tiny gap between two neurons where communication takes place. With experience and learning, these synapses can strengthen or weaken, new ones can form, and existing ones can be eliminated. This remarkable plasticity is not limited to childhood. Even older brains possess a remarkable capacity for change. This means that no matter our age, we have the potential to learn new skills, overcome challenges, and even recover from neurological damage. This understanding has revolutionized the way we approach brain health, offering hope for those seeking to improve cognitive function and manage neurological disorders. TMS, a magnetic window into brain change. Transcranial magnetic stimulation is a non-invasive technique that uses magnetic pulses to modulate brain activity. Imagine a gentle tap on the shoulder, not to move it, but to influence its activity. That's essentially what TMS does to the brain. It delivers focused magnetic pulses to specific brain regions, either exciting or inhibiting neuronal activity. During a TMS session, a coil is placed on the scalp near the targeted brain area. This coil generates magnetic pulses that pass painlessly through the skull and into the brain. These pulses induce electrical currents in the underlying neurons, altering their firing patterns. Numerous studies have demonstrated the effectiveness of TMS in treating a range of conditions, including major depressive disorder, anxiety disorders, and chronic pain. Unlike medication, which affects the entire brain, TMS allows for targeted stimulation of specific brain regions, making it a valuable tool for both research and treatment. Electric stimulation from surface to depth. Electric stimulation encompasses a range of techniques that use electrical currents to modulate brain activity. These techniques vary in their invasiveness and the depth at which they stimulate the brain. One well-known example is electroconvulsive therapy, a procedure that involves inducing a brief seizure to treat severe depression and other mental health conditions. On the less invasive end of the spectrum, we have techniques like transcranial direct current stimulation. TDCS uses weak electrical currents delivered through electrodes placed on the scalp to modulate neuronal excitability. It is a painless and portable technique that has shown promise in treating conditions like depression, anxiety, and chronic pain. By carefully targeting specific brain regions, these techniques can help restore balance in neural circuits and promote brain health. Section 5. Deep Brain Stimulation, Targeting Circuits for Healing. Deep Brain Stimulation, or DBS, is a surgical procedure that involves implanting electrodes in specific brain regions. These electrodes deliver continuous electrical pulses to modulate neural activity, much like a pacemaker regulates heart rhythm. DBS is typically reserved for conditions that haven't responded well to other treatments. It has shown remarkable success in treating movement disorders like Parkinson's disease, essential tremor and dystonia. DBS has also shown promise in treating conditions like epilepsy, obsessive-compulsive disorder, and even depression. By modulating the activity of these circuits, DBS can alleviate symptoms and improve quality of life for individuals living with debilitating conditions. While DBS is more invasive than TMS or TDCS, it offers a long-term solution for conditions that have not responded to other treatments. Section 6. Reorganizing the symphony. How stimulation reshapes neural networks. Imagine the brain as a vast symphony orchestra, each region representing a different instrument. When these instruments are in sync, the music flows harmoniously. However, when communication breaks down or instruments fall out of tune, the symphony can become discordant. This is where brain stimulation techniques come into play. By delivering precisely targeted energy to specific brain regions, these techniques act as conductors, helping to restore balance and harmony to the orchestra. They achieve this by influencing the way neurons communicate with each other, strengthening connections and promoting the formation of new ones. For example, in individuals with depression, certain brain regions may be underactive while others are overactive. TMS or TDCS can be used to either stimulate or inhibit these regions, helping to normalize activity and restore balance. These techniques help the brain to rewire itself, promoting adaptive changes that lead to improved function and symptom relief. Section 7. The gift of time, sustained benefits and brain regeneration. Neuroplasticity's effects can be long-lasting. Brain stimulation induces changes in neural activity, leading to sustained improvements. Think of it like exercising a muscle. The more you use it, the stronger it becomes. Repeated stimulation strengthens neural pathways and forges new connections. TMS benefits can last for months or years after treatment. DBS provides long-term relief from Parkinson's symptoms. Brain stimulation profoundly impacts brain structure and function. These techniques offer hope for long-term recovery and improved quality of life. Brain stimulation may promote neurogenesis, regenerating damaged brain tissue. Section 8. Seeking new possibilities, a call to action for brain health. Discoveries in neuroplasticity have shattered the old dogma of a fixed brain. We now stand on the cusp of a new era in brain health. TMS, electric stimulation, and DBS unlock the brain's potential for healing. At the Lado Healing Institute, we lead in using these technologies. Our experts provide personalized, cutting-edge treatments. We empower individuals to take control of their brain health. Seek a second opinion if traditional treatments haven't worked. Contact the Lado Healing Institute to learn more about our innovative treatments.